Carestream Dental is proud to show you today how to go smoothly to guided surgeries through the use of smart integration, combining Carestream Dental imaging solutions together with Swiss-made SMOP guided surgery solutions. CS Solutions for Implant Workflow is a digital integrated implant solution to support more confident diagnosis, improve treatment planning, better patient and referral communication, and greater confidence when placing implants. From 3D scans to the finished surgical guide, CS Solutions for Implants is a fully integrated and digital solution for implant treatment. Carestream Dental provides a wide and versatile range of cone beam CT devices, which offer multiple fields of views to support a wide variety of clinical applications. The CS8100 3D features 3D imaging, panoramic imaging, and model scanning all in one unit, and boasts the smallest footprint of any 3D system. The newest CS9600 platform enables new levels of image quality, usability, and ultimately precise diagnostic capabilities. Featuring intelligent automation, first-time right imaging technology, and highly simplified workflows, this system ensures reliable patient positioning and reproducible results. And for a future beyond today, the CS9600 can grow with the doctor's practice, thanks to upgradable fields of view, versatile imaging options, and added value software. With the CS3600 intraoral scanner, acquiring scans is faster, easier, and more accurate. This revolutionary scanner simplifies the scanning process with state-of-the-art, high-speed continuous scanning, an intelligent matching system for quick, flexible scanning, autoclavable tips in interchangeable orientations, and stunning high-definition full HD 3D images. CS 3D imaging software allows users to easily review CBCT images and share with referrals, as well as to plan implants. Users can also generate implant reports in a single click. All 3D data from Carestream Dental's CBCT units and intraoral scanners are stored centrally in a single imaging software to facilitate data management. Prosthetically driven implant planning starts by combining the data sets from a digital impression taken by CS3600 intraoral scanner or Carestream Dental CBCT on a conventional impression and a Carestream Dental patient CBCT scan. The two scans are automatically aligned in CS 3D imaging software to create a virtual setup with little to no manipulation from the doctor. CS 3D imaging allows doctors to virtually plan the crown and implant on the same screen to ensure that the implant is positioned according to the ideal future restoration and not the other way around. Doctors add the crown to the combined scanner and CBCT datasets and place the implant from a library featuring more than 70 manufacturers. They can also create their own implants and manage their own library. From this prosthetic-driven implant planning and the latest integration feature, Carestream Dental will show you how to transfer the implant planning to the SMOP Swiss meter in a single click and perform a surgical guide to perform a predictable implant surgery efficiently and smoothly.
Thank you for the introduction. Let me go back in time and show the evolution of 3D implant planning and guided implant placement, and what innovation we have seen in the last 20 years. So 20 years ago, we were using two-dimensional radiographs, panoramic images, to prepare implant treatments. In this case, you can see how we were able to see the prosthetic position by using a scanning template during the radiographic examination, and then being able to mark the risk structures and potential position for the implants. And we were even able, after the rough planning, to create something like a guiding template using at least the prosthetical information to make sure that the implants will be in a position where we prosthetically need them. Around 20 years ago, the world changed a little bit. From around 1996, CBCT scanners came on the market, which allowed in the dental practice to perform 3D imaging. The biggest innovation was probably the availability of fast computers, which allowed first time to surf through the slices of those images in your dental practice. As we can see here, were some of the first software systems for the 3D planning. It looked a little bit like a DICOM viewer. In my project at the University of Heidelberg, we tried in '99 to create an implant planning software which reduces complexity and gives you the best possible insight into 3D data. So here you can see different slices, like architects were showing the slices, not cross-sectionals, to be able to surf through the slices and to plan implant position. Even then, in '99, we used scanning templates. We needed reference markers to be able to transfer the planning into the mouth of the patient. So the patient even needed to carry templates during the scan in his mouth to then be able to mount those templates into machines or to transfer the planning to the execution. Here you can see a lab technician who is transferring manually the scanning guide, the scanning template, into a surgical guide. There were different machines. We had developed a mechanical machine, as you can see here. On the right side here you can see a stereolithographic printer that created a surgical guide in an automated process. And then we were able to use those surgical guides during surgery with first coming guided surgery kits onto the market. Around 2009, we now talk about 10 years of implant planning and guided surgery, there was a broad distribution of CBCTs. So in many practices we did find CBCTs, but I could see a lack of usability of 3D planning and guided surgery in these practices. As an engineer, we would have expected that if you create a CBCT, then you use it. You will read the data and you will use it for a surgical guide, for a 3D planning and for a surgical guide. But in reality, we realized that's not always the case. So we asked questions, what's the case? And the most answers were regarding ease of use and cost. So the feedback was we need to reduce complexity and cost so the surgeon or the prosthodontist would be more willing to use the full potential of the 3D scanning of the patients. Out of this experience, we created a project with the University of Zurich. I was part of the faculty until today. We went into studies and tried to optimize the existing processes to use new technologies on the market and to allow open interfaces, together with a team of young CAD/CAM developers in Zurich with the Swissmeda company. So our first goal was to get rid of the scanning template, because the scanning template needed in the 3D scan caused a lot of complication and cost. The idea was that you can scan the patient without any preparation, and then after scanning you can make a first diagnosis, understand if the patient can be treated, and if treatment is possible, or if the patient has the budget, or if you think you could do something there, then it can make sense to invest, and you can go further and create a wax-up conventionally, scan it, and import it into the software with an open interface. Or you do it even digitally and import it into the software. The same we implemented for the models, for the impressions that we would like to get an image of the intraoral situation, and where you can import it easily into the software. Today we can certainly also use digital intraoral scanners to have this process a little bit easier. Like this, we were able to reduce the complexity and the cost, and to allow all existing CBCT scans you did create of your customers, at least if they have accepted quality, for the full workflow, allowing 3D implant planning and even the creation of a surgical guide. Part of this process can be delegated to a service partner because part of this process may be too complicated. So we created a cloud solution that allows to share cases with colleagues, to ask them questions, or to delegate the complication to a lab, and that the surgeon and the prosthodontist can concentrate on the essentials. So as an example, in the case management software of the SMOP, you can click on the button sharing, and then the list of your friends pops up, the colleagues or your centers you connected in the internet, and in here you can share the case with your colleagues, you can ask questions, and they will have direct access on the original data on your case. If they change it, if you allow them to change it, it will even be changed. When you open the software next time, you will see what they did, and you can discuss about it. We then tried to create a specialized software for the purpose of implant planning through the practitioner. The idea was that the implant surgeon or the prosthodontist should have fun to learn the images, to learn out of the images the perfect treatment plan, and to have an intuitive interface to do so, to be able to do what you can see. You see the implant, you touch the implant, you can move the implant, you see that circle, you can turn the implant. There's a small button on the end of the implant. You can choose the original diameter of your implant brand and step by step move it up. And like this, you can try to find the perfect situation. You can surf through the slices, understand how the implant is placed, and you have a three-dimensional image which allows you to see three-dimensionally and to show it to your patient, to explain your patient what you did. We have integrated a wide database of objects, meaning we have, for some implant companies, we have abutments, scan adapters, so you can directly export the data and create provisionals. We translated it into the 6 most common used languages, and we made it available for Windows and Apple, as we really want to reach the ones that are treating the patients. So we designed the software to best assist to follow the rules we learned from the literature. For example, regarding the placement of an implant in the aesthetic zone. As Dani Busa and Urs Belzer and Daniel Wiesmeyer in 2007 had defined in the ITI treatment guide, we wanted to make it as easy as possible to define the optimal buccal oral position. As you can see here, we can surf through the slices and see the anatomic possibilities. This cut is this green line here, so I can easily surf through the slices, find what I have, and I can move the implant to the perfect position. I can change it and try to find the best match. We learned the importance from Stephen Chen also in 2008. That was shortly before we developed the software, that implants with a buccal shoulder position showed 3 times more recessions than implants with an oral position. And like this, we wanted to make it as easy as possible to place the implants following those rules. Regarding the mesiodistal position, again, you can see I'm surfing through the slices and I'm seeing my neighboring teeth. Gröndal already defined in 93 that a reduced horizontal distance between teeth and implants leads to bone resorption at the adjacent teeth. So we need some minimal distances. I learned 2009 from Mark Quirinen in his paper critical horizontal dimensions. What dimensions do we need? So we created this orange safety cylinder, in this case with a minimum distance of 1.5 millimeters. That means if two safety cylinders would touch each other, we would have a minimum distance of 3 millimeters to have a visual control of the distances. SMOP offers also additional tools to measure easily. The idea was always to have it easy and quick, not so many buttons, to be able, you know the rules yourself, but you're able to follow those rules in the software. We then tried to use new technologies as 3D printing. We created an open interface allowing to mill the guide with your milling machines or to use the advantages of 3D printing. But in 2009, not only in our university, we were examining advantages and disadvantages of 3D implant planning. There were also papers which showed some errors which we didn't expect. So as a mean error, Nele van Asche reported 1 millimeter or up to 5 degrees of error, but up to a range of 6 millimeters or 25 degrees. So the feedback was often that the overall precision is acceptable, but there can be significant outliers. Additionally, there were studies showing fractured, misfabricated and misfitting templates, meaning we were skeptical if we can really trust into the templates from our labs at that time. We made a project trying to understand how do surgical guides look like and why do surgical guides look like as they look like. And we developed a new game-changing technology to improve precision, to improve usability, and to reduce the effort and cost of guide technology. The surgical guides, as you can see here on the upper images, were not satisfying at all. They did not seat as expected. So our first preference was to improve the precision of the seating of the surgical guide. To improve it by developing a concept that makes sure that the contact areas of the surgical guide would fit like sucking points onto the teeth, as you can see on the lower images. It's important to create a template that can sit precisely, but this is not enough. Additionally, we need to make sure that you can easily check this position intraorally. So it was important to us to create the connecting supporting structures of the guide as thin as possible to enable you to see the areas where the guide will be seated, but to still design them strong enough to resist the force of your tools and hands. We realized this with a wireframe design, which thickness can be easily adapted to the needs of every individual case and every individual practitioner and style. So our concept results in an improved fit of the guide and in a better control of the fit. Precision is one important element, but usability may be even more important. So we wanted to make sure that you have a full visibility onto the cetus. We developed this new wireframe design also, as this allowed us to give you the best possible visibility onto the areas which will be relevant for you during the surgery. In most cases, we need to raise a flap. Sometimes a smaller area, sometimes a larger area. The use of a surgical guide should not reduce your options in flap design. So we designed the SMOP software in the way that the specific flap design you plan for an individual case can be taken into account, and the guide can be designed accordingly. Our method leaves you several options to raise a flap and still use a precise SMOP guide, even in the edentulous jaw. Additionally, the open guide design allows good cooling. And as we can avoid to add material onto the teeth, it allows an easier access of the surgical instruments. The precision and the usability of the guide is crucial for your success. But as we had learned, we need to additionally reduce complication and cost of the process before you will use our surgical guides in a daily routine. So we developed a special software that allows us to design the surgical guide very easy and fast. When the manual creation of a surgical guide took the lab technician several hours in the past, our goal was to reduce the time for the design to only several minutes. And we wanted to give you the flexibility to either delegate the design and manufacturing to a specialized service partner, specialized SMOP service partner, or to your local lab via our cloud. Or if you prefer to do all the steps yourself, if you have the knowledge or the people who have the knowledge to learn it, if you have the machines, if you want to buy the machines, we offer chair-side versions with open interfaces for your practice and practice lab. I'm often astonished that still today we see many systems on the market that seem to just copy the past, just take manual methods and copy them into digital. For example, when the template design is just an offset of the model skin. Like when we were pouring powder and resin onto the gypsum models to design the conventional guides 20 years ago. The main reason to cover all the teeth and mucosa with so much plastic was probably the fact that the manual production process did not allow to do it different. But with the new digital possibilities, it didn't make sense to redo this design process completely as I had shown it to you. If you work in a team, maybe you have colleagues you would like to share the planning with, or somebody is preparing a planning for you. So in this case, we used our cloud also to access mobile apps. So we, as I had shown before, we additionally allowed to, with one click, to share the case with an iPhone or an iPad. So you can check the planning there and release it, send it back. We offered from the beginning the opportunity to use the system without upfront investment. The idea was you just pay a yearly membership fee, which is not so high, and then you pay a fee per use, a pay-per-use model. So you don't have to buy a software for thousands of euros or US dollars. No, you can just start, and if you don't like it, you can stop it, money back, or you go on and you have a low payment. So we offer different models. The first model is it allows you to use as a service partner who assists you with the steps. So you would do the scanning and the CBCT and the model, the impression in your practice, and then you would send it to our service center, or to our service partner, or to one of our service partners. We have service partners in many different countries, and they would support you in a way that they would help you within the 3D planning, and they would design the surgical guide for you. They will then print it to you, send it to you, and you could do the placement and the restoration. The second option is that you do the CBCT and the impression or the intraoral scan in your practice, and you even do the 3D planning in your practice. You could use the Carestream internal 3D implant software, and with this you could export it to the SMOP, and then you could send it to the lab, or you could do it with the SMOP from the beginning, and then via the cloud send to the lab. Now the cloud can support you creating, designing the surgical guide, and again print it for you and send it to you, or they could send you the file and you could print it yourself or mill it yourself if you would have the machines to do so. And then with this you could place the implant, do the restoration using the export possibilities. You could even prefabricate a provisional before the surgery. And the last option is the chair-side option that allows you to do all the steps by yourself. Maybe you're technically very, very advanced, so you could do the CBCT, the scanning, the planning, the surgical guide design, the surgical guide printing, placement, restoration, crown, whatever, everything in your own practice. Now my colleague Beat Kurt will go step by step into the details and show you some case examples.
Hello, My name is Beat Kurt. The workflow I present is the combination of Carestream hard and software and the implant planning software SMOP of Swissmeda. It combines the strengths of both companies for a better and easier workflow. The workflow starts with the acquisition of the volume data and at least an impression of the intraoral situation, followed by the planning either in the Carestream 3D or in the SMOP software, and the design and production of the template. What do we need for a perfect planning? I talk about hardware and software first. The acquisition of the DICOM data can be done by a Carestream cone beam CT 8100, 9300 or 9600. Also, cone beam CTs from other brands can be used. The most precise and easiest way to get the STL or ply data of a model is to use a Carestream intraoral scanner 3500 or 3600. Also here, other IO scanner from other brands can be used, but these scanners, they need an open export for STL data. Alternative ways to get the STL data of a model is to take a cone beam CT of a stone model or a conventional impression. It is also possible to use a surface scanner to scan the plaster model. Data acquired with a Carestream device allow an automatic merging of the volume and the impression in the Carestream 3D software. As soon as we have cone beam CT or STL data from another brand device, the SMOP software is necessary for the full workflow. Here are some tips and tricks for the cone beam CT procedure. The patient needs to stand or sit without movement during the cone beam CT taken. Bite has to be open. Teeth surfaces shall not touch. Tongue should not be pressed to the palate. The cheek and the lips should be kept back with cotton rolls from the teeth and the gingiva. When you do an intraoral scan, scan as much as you can. Try to scan the retromolar area. For partially edentulous or fully edentulous upper jaws, scan also the palate. For conventional impression, do it as precise as you can. Let's talk about software and licenses now. On the Carestream side, we need the CS imaging, the CS 3D imaging software, and a license for the PDIP module. On the Swissmeda side, we need the SMOP software and we need a license for one of the three options A, B or C Florian talked about before. Download the newest version of both software and install on the same computer. Then you can do the exchange of the data from one to the other software. After this introduction of the general workflow, I show you step by step the procedure for the possibility to transfer the data from the Carestream software to SMOP and how to delegate all or part of the steps to a service partner. And I also show the complete chairside workflow with the template design and print of the template. We start with opening the Carestream imaging software. Choose a patient with a 3D volume and a 3D scan. We open the 3D imaging software. In this case, we want to plan an implant in Regio 2-2. We have a good bony situation. We see it here also on the 3D volume. Our first step is now to import and align the impression of an upper jaw model. We click this model icon and now we can choose the upper jaw, the maxilla. We can align it, and there's a minimum of 6 ejected teeth when we want to have an automatic alignment. We agree. The alignment is done. And as you can see here, the alignment was really good in this case. We had enough teeth. We want to do a prosthetic-driven implant planning, and that's why I insert now a virtual wax up by the crown icon. I choose here again number 2-2, and now we can either do the positioning of this wax up here in the 3D volume, or we can go here and change it and go to the right place where we want to have it. Go a little more to buccal side, or as I told you here, we can also turn it here, change the axis, open it here a little bit more, and then we go a little bit buccal. Okay, so now we have the proper position of this wax up. I can show you again here in the 3D. This looks fine. Make it smaller again. The next step, because we are ready now, we can insert the implant and do the implant planning. We activate the implant tool. We go again in our position. We know about it will be 11 or 12 millimeter long, and there's a pop-up, and we can choose the brand of the implant and the type of the implant. It is always the last implant we have planned to is popping up, though in this case we go and choose an 11 millimeter 4.0 millimeter diameter Tommen implant. I press OK. The planning is completed, and I can export the situation to SMOP for ordering a template. For this, I click on the SMOP button. A pop-up appears, and I have to agree to the transfer of the data of the volume, the model, the implant position, and the virtual wax up to the SMOP software. I enter my password, and now we can choose if we want to create the case for the upper or lower jaw or for both jaws. The data is now imported to SMOP. This takes a moment. As soon as the data is stored locally, it will upload it to the SMOP cloud, and when this process is finished, you have access to the case from every computer or I/O device on which you have the SMOP software or app installed. From this overview from the patient shell, we change to the planning program. Here you see now the main desktop of the SMOP implant planning software. In the upper left window we have the 3D volume with the imported aligned model, with the wax-up and with the implant. In the lower left is the occlusal view. We can surf through the slices. In the upper right we have the frontal view, and in the lower right we have the side view. We now check again the implant if we are in the correct anatomic and prosthetic position. We go to the 3D volume, and it's better to let disappear the lower jaw. So we have the best occlusal view, and we see that the axis is to buckle. We change this in the side view. We turn the implant a little bit, and now this should be correct. You clearly can recognize the contour of the model, the contour also of the wax-up, and you see the sleeves for the guided drill kit. It seems here that the implant is a little bit too deep. I let disappear the safety cylinder, so I change this. We check again the axis, and now we can do a screw retain crown. Last check, and the case is ready to do the order for the template. To open the order tool, we first have to click on this export button. We have to approve the implant. Then we can go to the shopping cart, click here, and the order tool for the SMOP service center you have chosen will open, and you can choose your service. In this case, you only want to have the design and the print of the template. So here we have the design, and here we have the manufacturing of the template. But depending on the service center you choose, it's possible that you can order more services like the positioning of model, scan data, the wax up, even the implant planning can be done, or you can also order, when this is supported, a prefabricated provisional from the data of this planning. The prices of this service is depending on the service center you have chosen. The next step is that you confirm your address, and then you see the estimated delivery date, total price. You can add some additional information, and you have to confirm the terms and conditions, of course, and then send the order. Per email you get the confirmation that your order was placed. In 1 or 2 days you get again an email that you can confirm the planning of the template or the implant planning if you have chosen the full service, and then again a few days later you get your print. Now we have again our case from the Carestream software. I open the case. This time we only have the 3D volume. The rest we will do here in SMOP. In the top bar you see the workflow, so we can go from one step to the next one. And first one we have to define the occlusal plane and the bite spline. So we go here, make this spline a little bit smaller. This is important because when we are surfing through the slides, it goes along this line. Check from the side, looks okay. So we go to the next step. We now approve the occlusion and we import the maxilla ply file. We have here a semi-automatic alignment. For this we have to define at least 3 points. It's good when we go here, pick points, one here to the molar, on the other side premolar, and then we can do matching. There's an automatism who is calculating a better position, and when we agree, we accept. We have here now the matching with the maxilla. We can also check if this was okay. We go again in the region of our teeth, make it a little bit bigger to control, and you see the matching was really nicely done. What we also can do, we can import the opposite jaw. For this we go to extra model. Model is again approved. We name it. We choose the mandibular ply file. We use the same coordinate system because we took a bite when we have done the intraoral scan with the ply file. So you see it's in occlusion how we have taken it with the intraoral scanner. Our technician has done in his CAD/CAM program a really nice wax up, and now I import also this wax up. I choose it here, the CAD/CAM wax up, and it's automatically placed in the right position. So we are again ready to go for implant placement. We go to the next icon. Wax up is approved, and now we choose the side of the implant, and we can also choose here out of about 20-25 implant brands our preferred company. It's Tom & Medical in this case. Again, implant type, diameter we had before about 4 millimeters, length about 11 millimeters, and the implant is already placed close to the side we want. And now we can easily turn the implant in the right position. What I want to see is also the wax up. That's very important. We can here take away the lower jaw again, and then we have the position of the implant. It's now too deep a little bit. So this orange square here indicates a distance of 1.5 millimeter. This orange square here is the so-called safety cylinder. It's a distance from 1.5 millimeter. In this case, we know that we need 1.5 millimeter when we want to have no bone augmentation. We check again the position of this implant, serve through the different views. This looks nice. And now, not as before, I will also do the template design. I approve the implant. We go into the template designer. First step here is this icon here. We want to have not too deep undercuts, so I do the positioning of the upper jaw here of the model, and the next step is we place so-called clamps. I by myself prefer to have the clamps next to the implant side. We can place a few more here, another one here. We go a little bit in the undercuts, not too much, otherwise it will be too difficult to place the template. Also in the inner side, go here a little bit down, here a little bit up. So depending on the surgeon, you can do more or less of these clamps. So, and then next would be this icon here. We can go on the clamps, connect them. Here one, here we can do 1 or 2 points. We do the same for the outer side. Make it a little bit bigger for you. One here. Now here I need one more, otherwise it's also not so easy to place it on the teeth like this. Now it's better, and here one more. So, and one connection from the left side to the right side. Turn it around. So this looks nice. I can also change the sleeve. Now we have here a very close contact, so we have possibility to trim mesial and distal the sleeve. You see here when I make it big. And we also could change the direction of this sleeve a little bit. See, I can turn, and also here it's not necessary. And we are ready to do the calculation of this template. This is the last click here on the last button. For a case like this, it takes about 1 minute. You see already how the template is designed. As soon as it's yellow, the template is ready to print. I always check the template. I take away the model and I can check the template from all the sides. And yeah, that was it for the design of an easy one-tooth template. This template is now ready to print, so you can export the STL file to your computer, or you can send it to the service partner or to a print center that they print it for you. For those of you who want to have a little bit more support on the gingiva or on the palate, I have here another case. I will demonstrate how you can easily design a gingiva support. We can mark the area where we want to have our support. And then we do again the inner connection. I will show more templates later with my keynote presentation. Here we make connections again, here, 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 or we can take the outer connection here and go here, and then we do the calculation, and you will see you will have a really nice tissue support on the palate. It's calculated at the moment, and again, as soon as it gets yellow, the calculation has finished and the template will be ready. I again take away the implant safety cylinder, and now you can check this implant and the position where the implants will be. Really nice here, the tissue support. My last case I'm showing here in the planning software is a edentulous lower jaw. Here you see that we also can import a complete scanned upper denture as the opposite jaw. I take it away. This was the existing old denture in the lower. I take this wax up also away, and then here we have a so-called bone reduction guide. We have here the base part, and with the possibility to click in the upper part here, the template. It's easy also to do all-on-4 solutions. With this picture here, with this nice wax up and model, I finish the presentation in the software. When I was doing this presentation, I just had a similar case in my office. It's an implant in Regio 2.2. The video is about 90 seconds. As you have heard and seen now, Carestream and Swissmeda offers you the possibilities from a mostly delegated PDIP implant planning and template production to a full do-it-yourself workflow with many options in between. I am often asked, which printer do you recommend? Swissmeda recommends a PolyJet printer from Stratasys. Thousands of templates have been printed and the customers are very satisfied with the quality and the fitting of these templates. These printers, they print with the medical material MED 610. Of course, you can also print with consumer and lab printers. There are many on the market and more to come. The most important point here is that these printers and parameters are calibrated and you have always an identical workflow. As you can see on these pictures, I have tested different printers and workflows. It's very time consuming and it's not so easy to do a good setup. After these tests, I recommend a print center. You order your template and you get it. If printing and spending a lot of time in your basement is your hobby, of course, then you can print your own guides. Let's talk now about the SMOP template. One big advantage of the SMOP template is the individual skeletal template design. Most common are teeth or mucosa supported or mixed template, but your service partner can also design bony supported templates. Here are a few templates for a dentulous jaw, in this case only with a skew fixation in the palate. You clearly see that the design was done for a flap elevation to the buccal side with a good overview, and we can also do a good cooling with this design. The modification of this template is with the buccal mucosa support. Here you need 2 central incisions for raising the flap. Here is another modification with more fixation pins. This is up to the surgeon's desire. We also can design more sophisticated templates with integrated occlusion like you see here. Of course, we can also design bone reduction guides. Here you see one with the base template on the left and the implant guide combined with the base on the right side. Here are the printed 2 templates, and here an intraoral situation with a bone reduction guide. Now I will show you some clinical cases. This is an implant case with an immediate provisional crown. The patient had an external granuloma on tooth number 2-1. An intraoral scan was taken with the CS3600 scanner. Then the data was imported to the SMOP software and tooth number 2-1 was virtually extracted. We did a planning for a screw retain temporary crown. The planning was sent to my lab and the technician was doing the construction, the CAD/CAM construction of this crown in ExoCAD, and then he glued this temporary crown on a T-base abutment. This case was done fully guided with the Camlock guide system. Here you see the template in situ. The tooth was already extracted. Then the cylinder guided implant system, positioning of the implant, This is already the professional crown. The defect was filled up with some bio-os, and this is directly after the surgery. Here you see the end result and the X-ray 1 year later. This is the next case, 2 lower front implants. The main problem here was the direction of the implants and also the distance between the 2 implants and the distance to the neighboring teeth. These implants are from Straumann. These are 2 bone level tapered 2.9 12 mm implants. Here another case. We had to extract tooth number 2.1 and 2.3. We did an intraoral scan with the CS3600. These are the preoperative radiographs. Here is the planning in SMOP. We saw that we had enough bone for a good primary stability. This is the template. Also here the data was sent to my technician, and the technician was prefabricating a professional bridge. Same procedure as before in exocad. Here is the temporary bridge, fully guided implant placement, the professional bridge in situ, and here you see the before and after pictures. Here we have a case with multiple implants. Because of the fast and predictable surgery and outcome, the upper and the lower jaw can easily done in local anesthesia and in the same surgery, like here in this ortho case with 7 implants. Again, planning in the SMOP software. Here the 2 surgical guides for the upper and lower jaw. And here is the final result. And here now my last case, an all-on-4 case. We have done again the planning in the implant planning software SMOP. Here you see the guide, final OPG, and the smile of a happy patient. Thank you for your attention.
So what could be the next steps for learning, for getting inside the topic? So I have been asked to give a short overview about the scientific evidence and literature. SMOP was involved, so we had different studies regarding the accuracy, regarding the efficiency, and in the field of 3D implant planning and guided surgery. And we did also follow a lot of studies, or we supported a lot of studies in the volume design and volume comparison field. Swiss Med SMOP has different software applications for bone block design, for the visualization of 3D structures in the data, for example cysts, or even for the comparison of different volume data for scientific studies. If you would get deeper into our topic, just visit one of our courses. If you go to our website, we have an event section, and here we list the courses where we are personally involved, with sometimes with our service partners. There are additional courses of service partners, but these are the upcoming courses in the next month and in the next time, which are already planned. You can also go to the website, to the product section. Here we do have some product documentation and video tutorials. If you click on products, then you can see the choices of videos and tutorials.
In where you can start to inspect your cases. So once you are happy with
Additionally, we do have product documentation, PDF files as tutorials. So if you would like to use the SMOP, you could choose one of our options to register. I would recommend you register via one of our service partners who can then assist you in the learning and through the whole process. So the first step would be that you give us your name and address details. You can change your price plan. You choose your subscription. You could do credit card payment, put in your credentials. Click on next. Then you get an email with your login data and your password. If you click on the login and installation link, you can download the software, install the software, and log in and start using it. If you want to contact the service partner, this is a list of some of our service partners who use our system, who know our system, and who can assist you through the process.